Welcome to Click My Project. Our project title is Image Compression Using Mean, Removed and Multistage Vector Quantization in Wavelet Domain. Our modified title is Biometric Image Compression Using Enhanced Vector Quantization. Now we are going to discuss about abstract of our project. Our project abstract is Biometric Image Compression using enhanced vector quantization representation have been implemented in this project. Biometric is becoming the part of our day-to-day life, right from our home to workplace. For security and safety purpose, prime importance is given to a biometric. Nowadays, the biggest challenge in using the biometric data is about handling the data is increasing day by day. It becomes difficult to store and transmitting the data efficiently and effectively in less time. So we need to go for a different compression technique to overcome this problem. Enhancing vector quantization can even be used to transmitting an image in more and less important data items. By only storing the important ones, the image can be stored in amazing more compact fashion, and also avoiding the data redundancy at the cost of negligible storage in the image. We will have the uses of different compression of fingerprint, iris and palm images as it's widely used in the most of the biometric application. This work is done in MATLAB version R2013A. Using enhancing vector quantization, we can achieve the compressed image with a compression ratio MSE and PSNR. This is our system architecture for this project. First one is an image acquisition. Here we take one input image, then pre-processing the input image. Here we using the median filter for pre-processing stage, and IM resize function is used to resizing the input image. Then codebook generator is generated here using random function. Then if codebook generation is done means then it will go for a compression. In the compression method we using a enhanced vector quantization algorithm. Then decompression method is done. After the enhancement, after the compression method, we are applying the decompression method. Inverse EVQ decompression algorithm is applied here. Then the performance measures is calculated using MSE and PSNR and to find the compression ratio. Next one is a flow diagram. This is our flow diagram. First is one is an image acquisition. The first stage of any vision system is that image acquisition stage. The image acquisition is the digitalization and storage of an image. After the image has been obtaining or various methods for pre-processing can be applied to the images to performing the many different vision tasks requiring today. However, if the image has not been acquiring a satisfactory, then identified the task may not be achievable even with the aids of some from the image enhancement. First, capturing the input image from the source file by using a UI get function and the IM read function. Users can able to change the resizing the images by providing the pixel height and width the help of IM resize function. Then adding the salt and pepper noise, then removing the pre-processing stage. Can removing the noise in the images using a filter function. The noise in the images reducing the quality of the image. In order to improving the quality of the image, we normally employing some filtering operation. Here we applying the median filter. Median filter is used for filtering and considering each pixel in the images in turn and looking its nearby neighbors to deciding whether or not it's a representative of a surrounding. The identification noisy pixel is the median is calculated by first sorting all the pixels values from the surrounding neighbors into a numerical order and then replacing the pixel being considering with the middle pixel value. Next one is a codebook generator. The fingerprint image, iris image, palm image can be seen at the textural pattern of a flow orientation with a shape discontinuous for this particular nature of the fingerprint image and the need for retaining a fine details of the ridges and their interrelations. The enhancement vector quantization method is most useful. Enhancement vector quantization have been proved to be very important development in the search of the more efficient methods of image compression. The image compression method matching enhanced vector quantization have been implemented for every minimized pixels. Minimization have been obtained by subtraction the mean values of each patches from the patches. Matching result is a types of sparse approximation which involving finding the best matching projection of a multi-dimensional data onto over completing dictionary D. Then the decompression method, the image deconstruction is done using an inverse operation of compression is done in the decompression operation. The inverse of enhanced vector quantization method is applied is used here. Next one is a performance measures. The performance analysis is done by calculating the PSNR value. PSNR means peak signal to noise ratio. Is an approximation to a human perception of a reconstruction quality. It is calculated based on the MSE. MSE means mean square error rate. PSNR value is high for enhancement process. PSNR is commonly used to measuring of the image fidelity is the degree to which one image matches another, such as a compressor is a processed image to an original, that is a non-compressed image. Now we are going to discuss about output of our project. First open the MATLAB R 2013 version. Our project developed in MATLAB R 2013 version, and go to the current folder and select main guy 1.m file. Right click the file and click the run button. Now open the biometric image compression using enhanced vector quantization guide. Click the input image and selected one input image. Now I selected 6.jpg image. This is an input image. Then pre-processing is done. The input images is resized, then applying the salt and pepper noise and applying the median filter to removing the unwanted pixels in the image. Then codebook generator. This is used for random function and generating the codebook. Then click the compressed image. Now enhanced vector quantization method compression is done here. This is compressed image. Then click the decompressed image. The decompressed image is display here. Then click the performance measures. Here we calculating the MSE PSNR compression ratio. Thank you for listening. Our demo is completed. Thank you.